Now, chapter 7 is about the counting, the product principle, sum principle, factorial notation, permutation, combination, which you did see them in additional math. There is nothing new here, nothing extra added in the syllabus, so they are basically the same. So what I will try to combine these three. I will make one video lesson for this one, for D and E separately. Okay, let's get started. The product principle, if you remember, for mostly the examples and the exercise are with the maps from when you go from one city to another city. For example, the product principles, when do you use, and when you use sum principle. For example, from P to Q, how many ways you can go? You can count that there is a 1, 2, 3, right? So it's just sum principle. You add the possibilities. And for example, from Q to R, how many ways there are? From Q to R, there are 4. 1, 2, 3, and 4. But if you want to combine these two, like let's call them operations, two different operations, and I want to go from P to R. So in how many different ways we can go? We start from the P, then you can use the first one, P or second, P or third one, or the fourth one. So here we can use the product principle. If we have independent two operations, and if I can do one of them in 3 ways and the second one in 4 ways, if I want to find the total number of ways to go from P to R, I will just multiply them. It will be 12. And the common another example was, for example, wearing some. Okay, let's say you have 4 different shirts. In how many different ways you can wear them? So it's a 4 ways, right? And let's say you have 5 different pants of different colors. Let's say in how many different ways you can wear only pants. It will be 5 ways, 4 ways, and 5 ways. But if we put them on together, shirts and the pants, how many different, let me call combination, how many different, okay, not combination, outfit we can have with the combination of shirts and the pants? Let's call them outfit. So it will be 4 multiplied by 5, 20 different ways. Let's say you have 4 different shirts with the colors red, blue, yellow, and green, and 5 different pants. So for each shirt you have 5 different pants. For the second shirt you have 5 different pants. So it's just actually multiplication. And for the sum principle, just you need to pay attention. Here I did put it in the wordings. When you see and, it usually in the examples we will see, it means multiplying the possibility. If you see or, suggesting, it's you are adding the possibilities. So the sum principle, as I told in the previous part, is the same. Just have different possibilities and you add them up. Factorial notations, yes, we need to know it. For example, what's the 5 factorial equal? So 4 factorial is equal. So if you remember, 5 factorial was 5 times 4 times 3 times 2 times 1. Okay, if I have n factorial, so you just need to multiply starting from n till the 1, all the numbers. This one was factorial. And with the letters, just pay attention. N factorial can be written as n minus 1 factorial, or it can be written as n minus 1 times n minus 2 factorial. So you just stop in some point. Or again, it can be written as n minus 1, n minus 2 times n minus 3 factorial till you get 1. Okay, so again, you cannot go to the negativity. And also one exception, 0 factorial is always 1. Okay, let's see in practice this part. So how we can rewrite this fraction, this one, simplify as a, let's say, factorials. Okay, I don't have any factorials and I'm missing some parts to write 9. I cannot write, for example, numerator as a 9 factorial, right? Because I don't have 6 times 5. Okay, let me write. I don't have this part. So I'm missing actually 6 factorials. I'm missing 6 factorials. But imagine if I did put it in numerator, in order not to destroy the balance, I have to also put 6 factorials in denominator. So I can rewrite this new fraction as 9 times 8 times 7 multiplied by 6 factorials divided by this one. I can write as 3 factorials times 6 factorials. Now here the fraction, the balance is not changing. It's the same. I just multiply numerator and denominator by the same number. And now numerator, I can simplify it actually. Now I can write as a 9 factorials divided by 3 factorials times 6 factorials. Okay, so they are not asking about simplifying the numbers, they just want to rewrite in the factorial. And the second one, let's simplify it. There are only letters. How we can simplify? Numerator we can write it as n plus 1 factorial, right? Not like this, sorry. N plus 1 times n factorials divided by n minus 1 factorial. So it doesn't give me anything. So let me write again. I can write n plus 1 times n minus 1 factorial divided by n minus 1 factorial. So I'm actually using this idea, which I told at the beginning, using this idea. So now we can see that actually we have two similar parts, n minus 1 factorial. Now I can cancel that. So what will be left to me? N plus 1 times n, which is n squared plus n. So this is all about part A, B, C.